Now we're going to look at the concept of look-back time, or the fact that the universe is full of old light. Here's a schematic view of the universe's evolution over 13.8 billion years. On the left, the Big Bang, the inflationary era, rapid expansion, a dark ages before stars and galaxies formed, and then gradual expansion with acceleration in the recent history. And we sit at the right edge of this diagram. The light we see looking back in time is old light, as we'll realize. If the speed of light were infinite, light would reach us everywhere in the universe at exactly the same time, and we'd see the whole universe as it is now. But it isn't, so we see distant regions as they were in the past. And this is the idea of look-back time, the idea that distant light is old light. We don't recognize this in our everyday life because objects on the Earth, the light reaches us in tiny fractions of a second. There's no sense of look-back time. However, at the distance of the moon, it's noticeable, and we probably remember, or if you hear recordings of the Apollo astronauts sending their transmissions back to the Earth, there was a little radio delay of a second or two in a conversation, a little hiccup caused by the travel time of radio waves going 250,000 miles back and forth. The sun we see as it was 8 minutes ago. Sirius, the nearby star, 8 years old light that we receive nigh, and Andromeda, our nearest large galaxy, is 2.5 million light years away, so the light we see from it is 2.5 million years old. Now, small numbers of light travel time make no difference. To a star, 8 years is nothing. It will live millions and millions of years. And to a galaxy, even a few million years is nothing. Galaxies are billions of years old. But eventually, when we look far enough out in space, this light travel time makes a difference. And also, the further back in distance, the further back in time we look. And that means telescopes are like time machines. We can observe the history of the universe simply by looking deeper and deeper into space. It's a sort of superpower of astronomy. As we look at the introduction to the movie Contact, with that great director Robert Zemeckis taking some artistic license with Carl Sagan's book, we get the idea of light travel time in the form of radio and TV signals evocatively rendered.
Obviously a major malfunction.
Well, I'm not a crook. Robert Kennedy was shot in that ballroom.
We are free at last.
A sniper has fired at President Kennedy.
Thomas Martin. Or have you ever been a member of
Never found.
For something never before experienced. 1941. A date which will live in...
And we continue the season's final edition of our Maxwell House Good News of 1930.
Walter Winchell. Good evening, Mr. North American. All the ships at sea. Let's go to press.
That film was a zoom out in space and so back in time towards the Big Bang. And you can see that it wasn't quite right in terms of the timing, because we were in the solar system, but we were hearing the TV and radio signals from the civil rights era, which was half a century ago. That radiation has gone 50 light years and encompasses thousands of stars. The previous video showed that correctly. But it's an evocative idea that old light is distant light. Now what that means is it makes no sense to ask what the sun is doing right now. We are stuck with the finite speed of light. It's a law of physics, and so we see the sun as it was. We see nearby stars as they were. In the nearby universe, that's pretty close to now. And for stars, that's recent, because most stars are within dozens or a few hundred light years away. So we're seeing them as they were a small fraction of the time ago in their lives. When we go further out, we're looking at long ago galaxies, maybe millions of light years or hundreds of millions of light years. That's still quite a small fraction of the age of the universe. But with big telescopes and the power of their time machine capability, we can see the ancient universe. And that is indeed how we know what the history of the universe was, by direct observation. And now we've got back far enough to see very close to the origin of the universe, which is the Big Bang, the subject of our discussion. Here's how Hubble Space Telescope probes the early universe, and you can see how its reach has increased and has got back to more than 90% of the age of the universe. We are seeing galaxies as they were within 10% or even 5% of the age of the universe, close to the Big Bang, less than 500 million years after the Big Bang, in fact. And here, from very recent observations, is an ultra-faint galaxy seen when the universe was only 500 years old, a look-back time of 13 billion years. It's a faint smudge of light, but spectroscopy shows that it has a redshift of 8 or 9, meaning its light has been stretched almost a factor of 10 by the expansion of space as it traveled through space and time. Let's imagine what happens at the edge of the visible universe. Do we fall off, or do we simply run out of light? And that's the end of this topic.